Welcome back to the Explainer, everyone. Today, we are absolutely cracking open the invisible code that literally runs our daily lives. We're getting into physics, Chapter 3, Dynamics. Dynamics is basically the software behind every movement you make, every car you see on the street, every sport you play. It's the whole shebang, and we are going to decode that invisible software today, step by step. Let's get into it. Okay, so let's dive right into this. Here's our roadmap for today. First, an introduction to dynamics. Second, force, mass, and inertia. Third, we'll break down Newton's 3 laws. Then, momentum and collisions. And finally, we'll wrap the whole thing up with dynamics in daily life. All right, Section 1, Introduction to Dynamics, the study of changing motion. Now, dynamics is not just some dry textbook theory. It actually answers the real whys of our physical world. For example, why does a moving object suddenly stop? Right? Think about the invisible rules that actually govern that action. I mean, if something is moving, what exactly causes it to just halt? Well, the ultimate answer there is force. A force is simply a push or a pull that can change the state of motion of an object, and we measure it in a unit called the Newton. Basically, force is the thing that starts a motion, stops a motion, or changes the speed and direction of an object. Think about kicking a resting football on the grass, right? Your foot applies a force that makes it move. Or conversely, think about catching that exact same football when it's flying through the air. Your hands apply a force to completely stop its motion. Moving right along to Section 2, force, mass, and inertia, the resistance to change. So here's a secret. Objects are fundamentally lazy, and this brings us right to inertia, which is the tendency of an object to resist changes to its current state of rest or motion. It is a super simple but absolutely powerful rule of the universe. Basically, what is at rest wants to stay at rest, and what is moving wants to stay moving. Objects just don't want to change their state unless they're absolutely forced to. So imagine yourself just sitting in a moving bus, okay? When the bus is stopped and then suddenly accelerates forward, what happens? Your body leans back. Why? Because your body was at rest and stubbornly wants to stay at rest. But then, when the bus is zooming down the street and suddenly slams on the brakes, you fall forward. Your body was in motion, and thanks to inertia, it desperately wants to keep moving forward, even though the bus is stopping. You physically relate to inertia literally every single time you commute. And this brilliantly illustrates the relationship between mass and inertia. Picture an empty shopping trolley. It has low mass, which means it has low inertia. It's super easy to move. Now, on the other hand, picture a heavy trolley, absolutely loaded with groceries. High mass means high inertia, making it incredibly hard to push. As mass increases, that stubbornness, that inertia, increases right